So, as we have a continuation from the previous class that we had, in this case, we are still on our basics. We are still on the recap of our grade 11, still to consider one or two aspects that we had before we can consider the other part, which is meant for our grade 12 mathematics, working with the compound angles, identities, the double angle. So we are going to consider this as a recap, like I said, reduction formula, working with positive and negative angles, and also considering our cofunction and as well the special angles. All right, so this is it, guys. We do not have much to consider as we have done this one before. Remember that the reduction formula is actually used whenever we have got a condition where, let's say, the angles is not an acute angle, it is greater than 90 degrees. It enables us to write a trig ratio as any angle, of any angle that you're given in terms of an acute angle. So let me just have this one. Enable us to, what are we going to do here, to write a trig ratio of any angle, which is this angle that is greater than 90 degrees, as long it is not an acute angle. Any angle that is what? Greater than 90 degrees, all right? Which is not an acute angle. In terms of what? In terms of an acute angle. In terms of an acute angle. That's an angle which is less than what? Less than 90 degrees. All right, so we can have that as an angle theta or x, whatever that you're given, which must be greater than 0 but less than what? Less than 90 degrees. Any angle in within that interval. So the reduction formula is used to express those trig ratios that are more than 90 degrees, 100, 120, 270, 360, maybe 345 in that interval, 350, something like that. 540, 720, and so on. We can reduce them. So under the reduction, one, we must consider the use of our quadrants, which we had this in our grade 11 mathematics, that from the quadrants, we're going to consider as 4. We're going to divide them into 4 equal parts. That's the word from the quadrant concept, dividing these ones into 4 equal parts. All right. So that's from our quadrants. So from our quadrants, like I said, we are going to subdivide this into 4 equal parts, where we have got the first, the second, the third, and the fourth quadrant. Taking our angles from what? From 0 degrees. As positive angles, we are going to take them in the anti-clockwise direction. So in this case, positive angles in the what? Anti-clockwise direction. We are going to notice that this is 0, this is 90, 180, 270, back to what? To 360 degrees. which in each case there is an acute angle which can be found in each quadrant. In the first quadrant, there's going to be an acute angle here, an acute angle, an acute angle, an acute angle like that. So the exact angle which lies in that quadrant can be given. Okay, let's say the acute angle here is what? Is theta. Here, theta. Here, theta. Here, theta. The first quadrant, the angle is not affected. Remember, guys, we said we take our angles from what? From zero, from the point of the reference line of the 0 degrees in the anti-clockwise direction. So you're going to see that in the first quadrant, it was going to be like that. Meaning to say theta is theta. There is no effect there. It's already an acute angle. There's no effect there because theta is just theta there. There's no effect there. It is just theta. In the second quadrant, the exact angle is not this theta that we see there. That is an acute angle, the theta that we are seeing. It is an acute angle. The exact angle is the one that we are going to take from our positive horizontal axis, which is our reference axis from the 0 degrees in the anti-clockwise until we meet this line. This is the exact angle that lies in the second quadrant. So from 180 degrees of a straight line, we are going to remove this theta, the acute angle there, to have this remaining angle. So this whole angle that we are seeing there that is going to lie in the second quadrant will be what? 180 degrees minus theta. So that's the angle which is represented in the second quadrant. Going to the third quadrant from the same positive horizontal axis in the anti-clockwise until we meet this line. This is the angle that we are referring, all this whole part. So as we can see, we have actually extended from 180. There is a theta which is also included. So it is supposed to be 180 of the straight line plus the theta. So the angle there is going to be referred to as 180 degrees plus theta. Remember, theta is our acute angle. In the fourth quadrant, in the same anti-clockwise direction, from 360 degrees, we are going to get rid of this theta. So this is 360 degrees minus what? Minus theta. Those are positive angles. Those are positive angles. So we can reduce them into their equivalent acute angles as part of our reduction process, which is for all angles that are taken in the anti-clockwise. So guys, I'm going to show you the part of your reduction concept, but for now, I just want you to know that as we refer to the positive angles from 0 to 360, these are the angles in the first quadrant, theta, second 180 minus theta, the third 180 plus theta, the fourth one 360 degrees minus theta, and that is opposed when now we are dealing with the negative angles. So I want you guys to know both so that we do not have a problem, guys. When you're now doing these questions, you'll be now trying to change a negative to a positive because you are just used to this. It's one and the same. Know both. This is your final stage, guys, of mathematics where you are know everything if possible. All right, know everything if it is possible. So as of the negative angles taken in the clockwise direction this time, clockwise direction. The previous was what? It was anti-clockwise. We're taking them in the anti-clockwise. This time they are taken in the clockwise direction. Meaning to say our angles will be this way from our reference axis, which is at what? At 0 degrees. We are going this way. They are negative. So it'll be 0, 90 degrees, as a negative 180 degrees, as a negative 270 degrees, as a negative back to 360 degrees. But remember, it's what? It is a negative angle that we are referring to. We are working with the negative angles. So meaning to say, this is going to have an effect on our presentation. Minus 90, minus 180, minus 270, minus 360. It is the same thing, the application of our quadrants, first, second, third, up to the fourth. And in each quadrant, there is an acute angle, just like what we saw before. Theta being our acute angle, it is going to be in each and every quadrant. The concept is not going to change. The concept is still the same. Only that we are reversing the process now from the fourth in this direction, starting from the fourth quadrant. Remember, clockwise. So in this quadrant, the angle taken from the reference was going to be like this up to this line. This is the angle that we have. So as we can see, our theta is simply that angle that you have in the fourth quadrant, as it is just like what our first quadrant was. Only that it's a negative. So this will be minus theta. Fourth quadrant. Going to the third, as we are considering, guys, clockwise direction from the positive, or from the real, which is our reference axis in actual sense. What is our angle now? Up to this line. This is the angle that we want. So this angle here is a negative angle. How are we going to take it? So it was supposed to be minus 180 plus theta. But theta is this part here, this acute angle that is here. So it is supposed to be theta minus 180 of what? The straight line. Remember, it's a negative angle. Theta minus 180. Remember, we are at negative 180. So it's the reverse now. Theta minus our angle is being negative there. So that's theta minus 180 degrees. That is going to give us a negative angle. Opposed to 180 minus theta, this one in the second quadrant, as a positive angle. Remember, you're saying 180 degrees minus acute. This time is the acute angle minus 180. So here, this part here is the same, even if they write it as minus 180 degrees plus theta. We just started with the negative 180 plus, it's one and the same. Right? So do not be confused on this, that one. In the second quadrant, this will be our angle. As we can see up to here, the theta is involved there. The theta is involved. So we're actually supposed to add to say 180 plus theta. But remember, these are negative angles. So it's going to be minus 180 degrees minus theta. Or minus theta minus 180, the way that you want, minus theta minus 180. As we can see, both are positive. I mean, both are negative here. Negative, negative. So rewriting this, it can be minus theta minus 180. In the first quadrant, same from our reference, we are going to the first quadrant. We were supposed to be at minus 360, but there's the theta that is in between affecting. So the angle there will be what? Theta minus 360. So once we see theta minus 360, or it is minus 360 degrees plus theta like this, you know that you are in the first quadrant. Remember, this is your first, this is your second, this is your third, this is your fourth quadrant. It is only that we are dealing with negative angles. That's why we had to refer from the fourth quadrant up to the first, because we are considering a clockwise direction. In another case of positive angles, as we dealt with positive angles, the rotation is for what? Anti-clockwise. So these two guys, they are equal. They represent the same thing. What am I trying to say? The angle in the first quadrant, which is a positive angle, it gives us the same properties to the trigonometrical ratios as that in the first quadrant, but being a negative angle. The properties, guys, what I'm trying to say, in the first quadrant, there's what? Theta. As positive angle is just theta. The sine of theta, guys, and the sine of theta minus 360 degrees, they are the same. Those angles, they're equal, guys. In the first quadrant, as we see that they're equal. So in actual sense, we're just saying theta is equal to theta minus 360 from that understanding. But from the understanding that I'm referring to of the trigonometrical ratios. The same in the second quadrant. What is happening there as a positive angle where there is 180 minus theta? Whatever that you're going to do, guys, if it was sine 180 degrees minus theta like this, you are going to answer the same way that you're going to answer when it is the sine of minus 180 degrees minus theta. They're the same. They represent the same thing. If it is a cos, if it is a tan, whatever that you're given there, only that one of these represents a positive angle, another one, it represents a negative angle. But their properties, same. Same thing in the third quadrant where the angle is given as 180 plus theta. Maybe it's cos there, it's 180 degrees plus theta. It is the same question with the one that you are given to evaluate or to simplify or to reduce cos theta minus 180. They are all in the third quadrant, only that one is positive, another one is a negative angle. But they represent the same thing, whether it is tan, here you put tan, you put a tan, you put a sine, you also put a... The answers are going to be the same when reduced. They're going to be the same. So knowing both guys is important because you just know it is the same thing. There's no need for you to say when you are given a negative angle, you want to try to change it to be a positive angle. Yes, it is fine. You can do that. I'm not saying it's wrong, but are you saying that knowing this can be easy? The same in the fourth quadrant where there is 360 degrees minus theta. If they say simplify sine 360 minus theta or reduce it, the answers that you are going to get are the same to the ones that you are being asked when it is sine of what? Minus theta, because they are from the same quadrant. So therefore it is the same for a cos here, as tan, a tan. So these are the angles, positive, negative. In the same quadrant, they have the same meaning. This is what I'm trying to say. In the same quadrant, they have the same meaning. First quadrant, second quadrant, third quadrant, whether it's positive, whether it's negative. So with this knowledge, guys, we can reduce these now. It will be easier for us to apply our reduction concept. So as we have got this part, guys, I'm just gonna okay, let me just redraw this, and you have those positive angles, we reduce them. So remember, reducing is just taking them from the angles which are greater than 90 degrees to angles which are less than 90 degrees, which are acute angles. So as of positive angles, all right, as we saw before, the first quadrant, second, so we're gonna use the cast concept, cast like this, cast, cos, this is all, this is sine, this is what is tan. So the first quadrant is, we do not reduce it because that is already, guys, having a theta. We're going to focus in the second. Remember, that is 180 minus theta. This is 180 degrees plus theta. This is 360 degrees minus theta as we consider positive angles. Remember what we had there. So this is it, guys. We can reduce 180 degrees minus theta. They are greater than 90 degrees. The first quadrant, there's no need because sine of theta is already in simplest form. It's already in simplest form. So you're going to focus with other quadrants. Other quadrants. All right. I think what we can just do here is we can just have it as a table. I think that can help second, third, and fourth. I don't know if it's gonna be fine. So this is our first, second, third, and the fourth. So let's just have the first, the second quadrant. So as of the positive angles, the second quadrant is the one of what? 180 degrees minus what? Minus theta. All right. Let's just hope we're going to win here. This is the quadrant of 180 degrees minus theta as of the positive angles. Remember, you're talking about what? Positive angles. Then we're going to have the third quadrant. All right. This is the quadrant of what? 180 degrees plus theta. Then we have got the fourth quadrant. Okay, yeah, I think it's going to help us like this. The fourth quadrant. And that's where we have got 360 degrees minus theta as of what? As we are referring to the positive angles, all right? These are positive angles. So thus the sine, cos can be reduced, all right? In the second quadrant, this is the quadrant of a sine. Sine is positive there. So meaning to say the sine of 180 degrees minus theta can be written. Remember, theta is an acute angle. We're taking theta as an acute angle. Theta is an acute angle. Is an acute angle. And our focus, our major focus here is to enable us to write a trig ratio of any angle greater than 90, which is not an acute, in terms of an acute angle, acute, which is our theta, So we want to rewrite this as we see it with 180 degrees minus theta. We must write it in terms of the acute, in terms of theta, this theta. So since sine is positive, it's just going to be positive sine theta. Thus, we have reduced it to be written as a ratio, a trig ratio of the acute angle theta. All right. What about a cos? 180 degrees minus theta. In which quadrant? Second quadrant, where a sine is dominating, it means cos is negative, does not have a power there. So cos is negative. The same thing with a tan, where it is taken from the quadrant, where it is taken from that quadrant, it is sine which is ruling there. So meaning to say the tan is going to be taken as a negative. It is only sine that is positive in that quadrant. That is the one that is ruling. All right? Positive. Moving on to the to the third one. Remember the first, it was just in terms of that. So it's just all of them. They're just sine theta, cos theta, tan theta. So there's nothing much there. There's no reduction. There's no reduction. So the third quadrant, where tan is the dominating trig, this time is the king, and the rest will be negative. So sine will be negative this time. The sine of 180 degrees plus what? Plus theta. When reduced, it will be negative of the acute angle. Same as a cos of 180 degrees plus theta. This is not the quadrant for a cos. So the cos has to be negative. Only a tan is positive. That's our dominating trig. So it remains a positive there. It's the one that is ruling in this quadrant. In the fourth quadrant, where a cos is the one that is ruling, that is our positive. The rest will be negative. So meaning to say the sine that we are going to have of 360 degrees minus theta in the fourth quadrant is a negative of the acute angle theta. But cos, since that's its dominating quadrant, in this quadrant it dominates. As long we are talking about angle from 270 to 360, cos has a power this time. And that's positive. Tan does not have power this moment. So it is a negative, just like a sine. This is how you just have these quadrants. What is dominating there? Positive. The rest, negative. Sine, tan, negative. Cast, 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 cast. Like this. Cast. You can take it that way. There are so many ways. Some we have those mnemonics which start from the first quadrant going to the fourth. So I do not want to dwell in other mnemonics because we end up having confusion. The cast with this one, we can be even able to understand even if we move on with these studies of yours to maybe engineering and so on. You study those, you still have the same concept. So let us just maintain that one. All right. So that is it. For positive angle, this is dominating for all positive angles. For all positive angles. Meaning to say, even those angles that are just taken as 120 degrees, 150 degrees, 280, 300 degrees. For all, we can reduce them in that manner. But this is what I was saying, guys. The reduction is nothing but one and the same to what is happening to these negative angles now, these negative angles. The reduction, guys, is nothing but one and the same. Nothing but one and the same. Here, we now have to consider the first quadrant, which In our first case, we're not considering that one, guys. The first quadrant, there's nothing to be reduced. We do not reduce anything there in the first quadrant because that is for what? For theta. There is no reduction. There is just sine theta, cos theta, tan theta. There is no reduction. It is already an acute angle. But when you consider the negative angles, it has to be reduced. In the first quadrant, it's no longer theta, it's theta minus 360 degrees as we consider our negative angles. But the concept does not change as we apply our cast concept. All positive in the first. All right, so let me just use this table here. I'm just going to take that diagram, but guys, I'm just going to have the table combined so that we can properly see that, guys. It's nothing. It's nothing. It's actually nothing. So for all negative angles this time, we're going to consider for negative angles, just like the same concept here that we had before. We are going to have the first quadrant. This time it must be considered. It's a must for us to consider it. The first quadrant. In the first quadrant, which angle is it that we have when we are dealing with the negative angles? Theta minus 360 degrees. Remember that. Theta minus 360. That is our angle there. Theta minus 360 degrees. All right. Then we also consider the second quadrant. In the second quadrant, we saw that is the quadrant of minus theta minus 180 or minus 180 minus theta. Second quadrant, the quadrant for sine, is a negative angle. That is the quadrant of minus 180 minus theta or minus theta minus 180, no matter the way that you understand, guys, here. Then we move on to the third quadrant, which in that case as a negative angle, it is what? Theta minus 180 or minus theta plus 1, minus 180 plus theta, one and the same, or just theta minus what? Theta minus 180. All right, so let's quickly have this one so that we can finish. I didn't know that we're going to have a lot of things, but it's a recap, guys. But anyways, let's just do it because some of you guys will be saying, in grade 11, I did not do this. Our teacher did not even teach us this part. All right, no problem. There we are now. No one to say you are going to blame. It will be you and your final exam now. Because now, guys, we've got YouTube. So you're not going to say, I did not do this. Oh, no. All right. Fourth quadrant, that is what? Minus theta. The angle there is given as minus theta. So what I'm trying to say is that these angles that we see, which falls in each quadrant, they have same properties as before, as of where that angle lies. In which quadrant does it lie? If they lie in the second quadrant, whether it's positive, whether it's a negative angle, as long they are found in the second quadrant, same properties. In the third quadrant, same properties. So meaning to say that from here, we can write our answers from what we just had before. All are positive in the first quadrant. So thus, in our case, the sine of the angle theta minus 360 will be taken as the sine of theta, reduced to the sine of theta. That's reduction. Cos of theta minus 360 degrees, as we are in the first quadrant and all are positive, it's going to be a positive. Same thing as of a tan. So the tan of theta minus 360 degrees is supposed to be also a positive. This is what we have. Positive. All. But in the first case, when we were working with the positive angles, there was no reduction there. They were just already acute angles. So we were not seeing that reduction concept. But as we are dealing with negative angles, you can see that it's no longer theta that we see, so it must be reduced to a theta. Sine of theta, cos, tan, and so on. So that's the same. In the second quadrant, remember what we had here to say. In the second, it is only sine which is positive. So guys, it is the same thing. You are aware in the second quadrant. So it is only sine there which is positive, the sine of minus 180 degrees minus theta, because where it lies, it is the second quadrant for sine. So it is the one that is going to be a positive. So that will be positive sine of theta. The rest, they are negative. All of these, the cos. This is not a quadrant for cos. All right, does not rule. Does not rule in this quadrant. So it becomes a negative. The same with the tan, does not have power in that quadrant. So it becomes a negative. That's the case. The third quadrant, as we had it before, meant for what? For tan. Only tan is a positive in the third quadrant. Just like what we had for positive angles, it is the same for these negative angles. Only a tan is positive. So the tan of theta, the third quadrant, guys, the third quadrant, why did it tend to be theta minus 360? The third quadrant minus theta minus 180 there. It was just maybe an error of writing there, because this one I remember vividly talking about this as theta minus what? Theta minus 180. So this is it. You must be very careful. Your presentation minus 180 degrees. This is the only one which is a positive. That's the quadrant is for theta. So it is a positive. The rest will be negative. Talking of what? The sine and the cos. The sine of what? Theta minus 180 degrees must be a negative. That's not the quadrant for sine. So it must be a negative. Same with the cos. It's not its quadrant. It's not ruling there. So it must be a negative. If we move on to the fourth quadrant, negative theta, just like what we had before. This is the quadrant for a cos. Only a cos must be positive, so the rest will be negative. Only a cos. So meaning to say a cos of that angle in the fourth quadrant, which is minus theta, it is positive cos. It is only cos being positive. That's the rest. The sign of minus theta will be what? A negative. The same with a tan. The tan of minus theta will be a negative. Guys, can you forget this? You can't. You just need to work on your revision. So the moment, guys, you know the angle, because it's the same here, guys. You see that is the same. This is the same what you had. So the moment you know your angle to say, all right, this angle is this, and it lies in this quadrant, whether it's negative or it's positive, same answers, same answers, same answers, same thing. The reduction there is the same, nothing has changed. So when you are given an angle, what you just need is to know which quadrant does it lie, full stop. Once you know the quadrant where it lies, you're done. Whether it is a negative angle, whether it is a positive angle, there is a quadrant where it is going to lie, where it is what? Found. That's the most important thing. All right, so as we can see here, we managed to actually combine two things here, positive and negative angles at the same time. So we're just gonna, this is a revision, guys. I'm not gonna waste much time. We're just gonna look into questions where we are going to have an application. All right, so another aspect, remember when you were in your grade 11, you also had a concept where angles that they can be more than 360 degrees. All right. So for those angles that are more than, you just have to consider adding or subtracting 360 until we get this layout. Is it of positive? Is it of negative angles? All right. So that is how we can actually have that concept. So for angles, let me just put it this way. For angles greater than 360 degrees, greater than 360 degrees. All right, so it can be in terms of a negative angle. As long it is in terms of the value, it's more than 360 because it can be like minus 540 or it can be positive 728, whatever that you're given. So in our case, just considering not the sign, but the number, to say the number 360, as it is more than that, whether it's negative, whether it's a positive. For these angles that are greater than that, we can add or subtract. We can add or subtract 360 degrees. Subtract 360 degrees. In actual sense, you must be considering to the multiples of 360 degrees. You must consider multiples of what? 360 degrees. Maybe we have got a bigger angle. You just try multiples of 360, 360, 720, and so on and so on by multiplying by what? 360 to any whole number that you're given. So we add or we subtract 360 degrees until the angle is between 0 and 360 degrees, until the angle is or can be written in any of these, whether negative or whether they are positive, and until it can be written in form of those, which is they are between what? All the angles that we're talking about from 0 to 360. So That's the major case. So until the angle, all right, so until the angle is between 0 degrees and what? And 360 degrees. So in my case, it can be negative, it can be positive, as long it is in between 0 and 360. Whether positive or negative, anyone, guys. I'm not gonna refer too much. All right, so without wasting your time, we also dealt with core functions. So as for core functions, guys, I'm not going to dwell much to say where was this one taken from. If you want to know that one, revise your grade 11 mathematics. We had those ones. So core functions, they allow us to write a ratio of a sign in terms of cos or vice versa. That is the major part of our core functions. Yes, that is the major case. All right. So allow us. All right. Guys, grammar. Allow us to write a ratio. In case of our syllabus, we work with sine and a cos. All right. Sine and a cos. All right. The ratio of sine in what? In terms of cos or vice versa. All right, there's no need of us having a bracket here. Let's just say and vice versa. So meaning to say I can change a sign to be written as a cos, or I can change a cos to be written as a sign of something. How is that possible? Those are the core function concept. All right, from the complementary angles, remember that complementary angles of two angles adding up to 90 degrees, that's where these ones were formed. Say if this is 90, this is theta, then this angle will be 90 degrees minus theta. So you're talking about the relationship of 90 degrees minus theta to theta, but also it can be something that is above 90 degrees minus theta, which can be referred to as an angle that is outside of the right angle triangle. So let's say here we consider something like 90 degrees plus theta. That's an obtuse angle, that one. Right? So like I said, guys, I'm not going to dwell into that. All right. So where theta is an acute angle, it follows that the sine of 90 degrees minus theta is equal to what? The cos of theta. Remembering that theta is an acute angle. Theta being what? An acute angle. All right. And also from this, the cos of 90 degrees can be changed. Remember, we're changing cos to a sine. So it's going to be the sine of theta. Sine of theta. But it therefore follows that when we add it this time to say it is sine of 90 degrees plus, the moment we add 90 degrees plus theta, it's no longer the concept of complementary because it's above one, is above 90 now. Remember, complementary, they are supposed to add up to 90. This one is above. But still, an angle that is above 90 degrees, where an acute angle is being added, that angle is going to lie in the second quadrant. This is 90 degrees. Remember, theta is an acute angle, so theta cannot be 90 degrees or something. That it's going to be an acute angle, something like this. Let's say this is our theta. So 90 degrees plus theta, we talk about the combination of this angle. That's our 90 degrees plus theta. In which quadrant does it lie? It lies in the second quadrant. Remember from your cast concept, in the second quadrant, there is only a sign which is positive there. So it follows that the sine of 90 degrees plus theta is a positive value. So therefore, the cos is supposed to be a positive value again, because sine is positive in the second quadrant. But when it is cos 90 degrees plus theta, because the quadrant where it lies is the second quadrant, which is the quadrant of a sine, cos is what there? Cos is a negative. The answer to the whole of this thing, if you simplify, it gives you a negative answer. So thus, our answer is to be a negative. So it must be negative. But remember the cofunction concept, guys. We are changing cos to a sine, sine to a cos. The whatever that you're going to get here must be a negative answer. So it must be negative what? Sine of theta. So the sine of theta, yes, it's a positive, this one. But once multiplied to the negative, it becomes what? A negative value, so that it caters the negative that we had for what? For cos. It caters that one. It takes into that negative that was on a cos from the quadrant concept, the quadrant that you are dealing with. The quadrant that you are dealing with. Also, it can be a condition where this now is taken to the fourth quadrant. When we've got something like theta minus 90 degrees. You just consider the same thing, guys. Because theta minus 90, this is a negative angle. Theta is an acute angle. So an acute angle minus 90 is going to give us something like this in the fourth quadrant, where cos is the only one which is positive. So if cos is positive, it follows that if it is cos theta minus 90 degrees, whatever that I'm going to have there must be positive. Why? Because cos is positive. But sine is negative in the fourth quadrant. So whatever that I'm going to get there must be a negative. Guys, revise as many questions as you can. But this is the major case that you need when answering your questions. If you can understand this, you are done. You can answer as many questions as you can in terms of your revisions, guys. This is the most important aspect. All right, so like I said, we have got the reduction formula, considering positive and negative angles, then also cofunctions. We are going to consider the last part, which is of the special angles, as a recap. So remember our special angles, like I said before, that actually there's nothing special about these special angles that we call special angles, because whatever that we have from there can be simplified from a calculator. But anyways, as you are to consider the special angles, we are referring to 30 degrees, 45 degrees, 60 degrees. Actually, we have a 0 and a 90 degrees. Those ones we are supposed to just know their answers to say the sine of 0 degrees is 0. But when it is the cos of 90 degrees, it is 1. And when it is the cos of 0 degrees, the cos of 0 degrees here is a 1. When it is sine of 90 degrees, it is a 1. But when it is a cos of the same angle, 90 degrees, it is a 0. All those must be known. They are to be known. You just need to know that. But do not even worry, because when you have 0 degrees and 90 degrees, just use your calculator. So that's why we are going to eliminate that part on our special angles and just concentrate with these 30, 45, and what? And 60 degrees. The reason why we need the triangles for the special angles, or for us to also know the basics, it is because the calculator, yes, it gives us these special angles, but in the simplified manner. Let's say the sine of 60 degrees, it's square root of 3 over 2. All right, this one is okay. I want something like where we're gonna have to rationalize, like the sine of 45 degrees, like this one. the sine of 45 degrees, square root of 2 over 2. It does not mean exactly that it was the opposite there as it is. Remember the ratio of a sine, it's opposite over hypotenuse. It does not mean this is your opposite, this one. This is your hypotenuse, no. It was something that was simplified to give us this. The calculator simplifies, it does not give us the earlier stages that we obtain when you use direct these special angles. So that's why we just need them, all right? So for 45 degrees, the triangle from our grade 11 mathematics, guys, we saw that it was like this. This is an equilateral triangle. For us to have 45 degrees, it's an isosceles. Where am I getting equilateral? An isosceles, guys, that's an isosceles triangle where these two must be equal from the opposite what? The opposite angle concept. So that's, if we name this 1 and name this one 1, from our Pythagoras theorem, we're going to calculate this side, the square root of what? Square root of 2. So it follows that we can determine the ratio, the sine of 45. Guys, this is the same thing. This 45 and this 45, they represent the same thing. So we're just going to consider one of these angles, all right? So let's say we consider this 45 degrees. What does it mean? It simply tells us that this is our opposite. I just need us to have, like to say, this is opposite. This is our adjacent, and this is our hypotenuse, according to this 45. But still, even if you use this one, name your sides opposite, whatever that you have, you're going to still have the same answers. You're going to have same answers at the end. So this is what we have here. So the sine of the angle of 45 degrees from opposite over hypotenuse. SOHCAHTOA concept. Opposite over hypotenuse. Our opposite, that is 1, over the hypotenuse, that is the square root of 2. So you see now that sometimes we might need the 1 over square root of 2 before it is simplified, before that. Sometimes we need, when it is simplified, like what we saw from our calculator, the sine of 45, which is what? Square root of 2 over 2. It is one and the same thing that we see here. If we simplify this 1 over what? The square root of 2, like this. You see, square root of 2 over 2. From rationalizing of that denominator. It is one and the same. One and the same. So you just have to figure out now, according to the question, am I going to put this or I'm going to put this one? If you are confused, then put the exact one that you get from your triangle, then simplify from there. All right? The sine of 45 and the cos of 45 are going to give us the same answer. Anyways, cos adjacent over hypotenuse, our adjacent is 1, hypotenuse is what? Square root of 2. So as we can see, it's just one and the same, square root of 2 over 2. Then we also have the tan of 45 degrees from the ratio of a tan, which is what? The opposite over the adjacent. Opposite is 1, adjacent is 1. So it was going to be 1 over 1, which gives us what? A 1. This is the exact answer, guys, from your calculator. Take your calculator and say tan 45. 1. Cos 45. Square root of 2 over 2. The same thing. The square root of 2 over 2. So these answers, it's not to say the triangle has got something, is those answers that we are used to. Only that we are dealing with what? The special angle property of what? Of a triangle there. That is the only thing. So if we move on, we have the one that is 60 degrees and 30 degrees. Those ones are to be taken from another triangle, but same concept, just like before the SOHCAHTOA concept. So the triangle for this one is like this. All right, it was supposed to be actually a complete like this one where we just took one of the sides. It was supposed to be a complete triangle like this, where this is 2, 2. The whole of this side is supposed to be 2, but because it is subdivided now into 2 because of the line of symmetry, this will be 1, 1. It is a right angle triangle. It is also a right angle triangle. These two guys, they are just identical because we had the angles 60, 60, 60. The whole of this angle was what? 60 degrees. But now because of the line of symmetry divided into 2, so that means it's going to be 30, 30. So this will be 30, this will be 30. So this triangle and this triangle are exactly the same. So instead, let us just work with one triangle. And for us to consider both triangles, guys, we're just going to consider only one. So considering this triangle here, thus let us try to apply our Pythagoras theorem to calculate the third side. This one, we're going to get square root of 3 from hypotenuse squared minus the shorter side squared. So that's 4 minus 1, which is 3, but it must be under what? The square root. So use your Pythagoras, you're going to get what? Square root of 3 representing that. So that's, we can determine our ratios, guys. Anyone. So let's start with 30 degrees. According to the angle of 30, sine of 30 degrees is what? Opposite over hypotenuse. Opposite over hypotenuse, 1 over 2. Same answer that you can get from your calculator. The cos of 30 degrees adjacent over hypotenuse, our adjacent over the hypotenuse, square root of 3 over what? Over 2. There's no need for us to simplify that one. Then the tan of what? 30 degrees. Adjacent, opposite over adjacent. So according to this, opposite is 1, adjacent square root of 3. So that's going to be 1 over square root of 3 according to the angle of what? 30 degrees. So this, when simplified, if you rationalize, guys, that is going to give us square root of 3 over what? Over 3. You can just even use your calculator, guys. 1 over what? 1 over the square root of 3. Okay? So that's the square root of 3 over 3. And we can also tell that same thing for the 60 degrees. Sine of 60 degrees. What do we have? Opposite. According to 60, this is our opposite over the hypotenuse. So square root of 3 over 2. The cos of 60 degrees, according to 60 degrees, our adjacent is this one. So that's 1 over 2. Adjacent over hypotenuse, 1 over what? 1 over 2. The tan of 60 degrees can also be determined. Opposite over adjacent. According to 60, this is the opposite. Your adjacent is what? Is 1. So that's square root of 3 over 1, which is going to give us what? The square root of 3. So as we can see, guys, we can simply play around with this. So there's actually nothing special about these special angles, guys, because you can even memorize them, know them by head without drawing the triangle. To just say you are given tan 60, you can just say tan 60, square root of 3. So where it is possible, where you see that the calculator can be just used, use your calculator, guys. Use it. Then simplify. Using the sets. Remember, we had the sets in our grade 11, so you must go back to those revisions of sets. Application of sets, addition, subtraction, those rationalizing of the denominator, this and that. It's your grade 11 mathematics, remember? So do go through that part. We are going to look into questions and application of what we have done as questions. So I want you to go through these questions. Those will be for our next class. So I want you to go through these so that if we are to have a revision, you'll be knowing, or you'll be having questions to say, okay, I did this question, but I couldn't manage to get the answer because of, okay? So we're going to have revision in our next class. So make sure you do prepare yourselves, all right? Answer as many questions as you can, all right? Answer as many questions as you can using the information that we have applied so far. This information, use of the special angles, the core function concept, the reduction formula concept for negative angles as well as for what? For positive angles. As reduction is considered, it's for both positive and negative what? Negative angles. So do revise this so that as we are going to have questions, you know where exactly this is taken from. So let's revise, guys, as many questions as we can.